So I'm going to be talking about magmatic sulphide prospectivity of the Labrador Trough, focusing more so on crustal contamination. So just a little bit up the superior craton from where the talks have been this morning. Just as a quick mention, since I'm quite honoured to be talking at a symposium on it to Tony. It was Tony who first introduced me to magmatic sulphide back in 2016 in an undergrad presentation. So thanks, Tony. So the Labrador Trough has been the focus of exploration for magmatic sulphides for almost a century. However, only a handful of sub-economic occurrences have been identified to date. One of the most recent of which was the Huckleberry prospects back in the early 2010s. On the way back for some airborne reconnaissance in the south-central Labrador Trough, a geologist spotted this outcrop here that we see on the screen, these two orange stains. They landed, grabbed some samples, and that then evolved into the now Huckleberry prospect. So I'm going to be adding a bit more of the context on how these prospects are formed and have an idea of how we might look for some more of them. The Labrador Trough represents the easternmost segment of the circumsuperior large igneous province. It hosts voluminous mafic-ultramafic rocks of the Sill complex that are temporally related to other mafic-ultramafic rocks in this large igneous province, which includes those at the Cape Smith and Thompson nickel belts. So as we know, those in the Cape Smith and Thompson nickel belts are host to world-class magmatic sulphide ores. So why aren't we seeing any similar mineralization in their easternmost cousin, the Labrador Trough? So zooming into this black hatched box, we get this diagram now to our left. This is a lithotectonic map of the area. Over to the east, we have the Nain craton, famous for the Voisey Bay deposit. In the center, we have the core zone, or Southern Ray craton. Sort of around here, we have the Labrador Trough, also known as the Ni-cu-pge origin, which is then bound to the west by the superior craton. The diagram to the middle represents the spatial extent of the Sill complex, given in red. As we can see, it spans around 800 to 900 kilometers in strike, depending on which literature you read. And they also have an extrusive component given in blue here in the side. So the squares here represent sub-economic prospects, which have been coloured by their respective host rocks, which I'll elaborate on shortly. In addition to a large amount of mafic-ultramafic rocks at a craton margin, the Labrador Trough does have a large number of northwest verging faults that are thought to propagate to the base of the crust, which would act as an ideal migration conduit. In addition, they have a lot of sulphide-bearing country rocks, which would act as an ideal assimilant for any hungry mafic-ultramafic magmas passing by them. These drill cores to the bottom right, so these are 4 centimeters in diameter, and these are the country rocks around the Huckleberry prospect. So as we can see, they're quite rich in sulphide and would act as an ideal assimilant. I should note that there's quite an interesting spatial relationship between these features and known prospects as well. On the screen now are the 3 primary sill types that we observe in the Sill complex. Perhaps the most important of which regarding sulphides is these thick gabbro-peridotite sills, which have a base of whorlite cumulates overlain by olivine gabbros, and magnetite gabbros. In the base of these units, there's disseminated up to semi-massive sulphides. At Huckleberry, this is what we're seeing in drill core at the base of this sill. It's a fine-grained melanocratic rock, but it has these sort of rounded, resorbed plagioclase glomerocrysts that have been assimilated from the underlying glomeroporphyritic gabbro, which leads us nicely into the least conspicuous sill type in the Sill complex, is these spectacular glomeroporphyritic gabbros. Rather than forming one thick sill, it seems that they form a series of sills stacked upon one another, which are identifiable by an increase in size and abundance of plagioclase glomerocrysts in each of their respective sort of sub-sills or sills. At the base of these stacks, they have globular sulphides, where adjacent to sulphide-bearing country rocks, but of economic interest in this particular unit is disseminated to net textured sulphides we see in glomeroporphyritic gabbro that directly underlies whorlite cumulates of this sill type. The final sill type in the Sill complex is these aphyric gabbros that form sill stacks in a manner similar to glomeroporphyritic gabbros. However, they don't have olivine cumulates, but they do have these stratiform gabbroic pegmatites as well. Like the glomeruloporphyritic gabbros again, they have globular sulphides at the base where adjacent to sulphide-bearing country rocks, but of economic interest is this disseminated to net textured sulphides spatially associated with these gabbroic pegmatites. The diagram now to the left is a plot of tonnage against average nickel grade for those sub-economic prospects that have had some sort of formal resource estimation. As we can see, they're a little bit smaller than the Thompson and Cape Smith deposits, which plot over around, I think, 100 million perhaps. And then on the plot to the right, we have average nickel against average copper grade for those prospects. As we can see, those hosted in gabbro-peridotite sills generally have more nickel relative to copper, vice versa for those in glomeruloporphyritic gabbros. And then those in aphoric gabbros have generally low amounts of base metals, and these are essentially PGE prospects. So the question remains as to whether there is any economic magmatic sulphides hidden in the Labrador Trough. And we're going to use our Huckleberry and Ni-cu-pge prospects as our representatives. At the top, we have a diagram of primitive mantle normalized PGE profiles for the different sill types. So in the gabbro-peridotite and glomeruloporphyritic gabbro sills, we see an almost identical pattern of positively sloping and slight negative gold anomalies. Copper palladium values are generally in excess of mantle range. Palladium iridium values are generally below 500. And R factor estimations based on these metal contents generally are below 5,000. For Ni-cu-pge prospect, however, we have low nickel and IPGE concentrations and relatively high PPGE concentrations. Copper palladium values are generally below that of mantle range. Palladium iridium values are slightly higher, but not that much higher. And R factor estimations are generally in excess of 10,000. So we did some laser work on the sulphides in each of these environments and produced a mass balance with the whole rock geochemistry, which is what we're seeing underneath. So for a mass balance at the gabbro-peridotite and glomeruloporphyritic gabbro sulphides, we see a fairly similar pattern again. A large proportion of the IPGE and rhodium are hosted in base metal sulphides, 20 to 30% of the palladium is, and small amounts of platinum and gold are. Over in the Ni-cu-pge sulphides, a relatively lower proportion of IPGE and rhodium are hosted in the sulphides, similar amounts of platinum, palladium and gold are. And this is fairly consistent with the platinum group mineral assemblages we've identified in each of these rocks. I just don't have enough time to just expand on that comment today. So we've seen a few similarities between the sulphides in the gabbro-peridotite and glomeruloporphyritic gabbro sills, and there's a compelling amount of interaction between them in the drill cores and in field outcrops as well. In downhole geochemical plots of boreholes drilled at Huckleberry, at the base of the gabbro-peridotite sill where it's underlain by glomeruloporphyritic gabbro sills, we see this downward decreasing tail of things such as magnesium, chromium, and chalcophile metals. So we believe that actually this represents sulphide and melt percolation from the gabbro-peridotite sills downward into underlying glomeruloporphyritic gabbro sills. The broader implication being is that economic sulphides that we believe are in the glomeruloporphyritic gabbro sill have perhaps percolated downward from stratigraphically overlying units, and they should be the exploration target in the area. So to assess crustal contamination, you can look at whole rock geochemistry. I haven't shared it in this particular slide because it doesn't show much compelling evidence for any contamination. So I've skipped right to sulfur selenium values. For whole rock sulfur selenium values in the sediments, they're generally in excess of 10,000. Mafic-ultramafic rocks have sulfur selenium values generally ranging from around 1,000 to 4,000. We see essentially a similar distribution from in situ analyses of sulphides. Sulphides in sedimentary rocks are in excess of 10,000, as we're seeing at the top here. However, magmatic sulphides in each of these environments have sulfur selenium values ranging from 1,000 to 3,000. We accredit this to some sort of post-magmatic sulfur loss, perhaps due to hydrothermal alteration, which is evident in the rocks. So this post-magmatic process may have masked any synmagmatic sulfur gain through processes such as contamination. So perhaps sulfur selenium values aren't the right tool for the job in this case. So we did some multiple sulfur isotope work at the University of Western Australia just before lockdown, I should add, so very lucky to have got there in time. I should add the samples I'm going to show you, we found no evidence for archaea and sulfur, so there's no CAP33 anomalies in these samples. The crustal sulfides do have quite prominent delta 34 sulfur anomalies in excess of +15. We overlaid globular sulfides from both prospects at the base of those sill stacks I showed you in a previous slide. Each of these have crustal signatures, generally above +2, more variable for those at Huckleberry. If I add those economically interesting sulfides from prospects, At Idefix, we see that the majority of those disseminated sulphides do have crustal signatures in excess of +2. However, those at Huckleberry generally range from -2 to +2, so essentially have a mantle signature. I should add that R factors are in excess of 10,000 at Idefix, so it's completely feasible that there has been some degree of isotopic exchange that has somewhat diluted a crustal signature in these rocks. However, at Huckleberry, R factor estimations don't exceed 5,000, so it's unlikely that any isotopic exchange has significantly impacted the signature. So we believe this is a true mantle signature at this point. What is interesting, though, is that one sample of sulphides in gabbro peridotite sealed had a high delta 34 sulfur anomaly, around +12 to +15. The sulphides in this particular sample have a much lower nickel copper tenor and much lower concentrations of platinum group elements than sulphides in other samples. So we hypothesize this is actually a crustal sulphide xenomelt. And what it indicates is that there has been at least some degree of sulphide interaction at Huckleberry. Unclear how influential such a process is at this moment. In the final discussion slides, we've got an R factor model that's overlain with sort of fractionation indices for copper iridium against nickel palladium. We used a starting concentration of olivine phoric basalt from the Cape Smith belt. I can elaborate on that in the text if anyone wants to know more. When we overlay sulphides at Huckleberry and also those at Lacretti, which is a similar deposit type to Huckleberry in the southern Labrador Trough, we can see that R factors range from around 500 to 5,000, and those at Idefix are generally in excess of 10,000. What's interesting is that sulphides in both prospects are consistent with up to 75% sulphide fractionation, which indicates that perhaps we're only seeing a small residue, fractionated remain almost, of a larger sulphide liquid body in the Montigny-Sill complex. Finally, the majority of occurrences do occur near to crustal sulphide repositories in the Labrador Trough, as sort of indicated by this diagram to the left. Prospects such as Idefix do require crustal contamination to achieve sulphide segregation. Prospects such as Huckleberry, however, are less clear. What is clear is that there is evidence for localized interaction between the parent magmas and the crustal sulphides, yet it's still unclear how influential such a process is for ore formation. At this stage, it's apparent that it's probably mantle sulfur. The composition of sulphides at both prospects suggests pre-emplacement fractionation of up to 75%. The broader implication being is that further nickel-rich ores may reside elsewhere in the plumbing system of the Montigny-Sill complex, which interestingly is a similar conclusion to other prospects in the north of the Labrador Trough, such as Hope's Advance. So perhaps this is a common theme for sulphides in the Montigny-Sill complex. Thank you for listening. Here's some publications sort of published in review from the study. I thank any reviewers in the audience today. And this is an image from doing some fieldwork in Labrador. I remember speaking to Sarah Jane at the Platinum Symposium a few years back. She suggested the flies may get the better of me in the Labrador Trough, and she was right. They did. So thank you for listening. Any questions, please drop them in the text.